My name is Dr. Pritam Chattopadhyay. Presently, I am working as an assistant professor in MUC Women's College, Bardhaman, under under University of Bardhaman. I have done my PhD in plant molecular biology, and for last 10 years, I am involved in working in fermentation technology and host microbe interaction. So, with brief introduction about myself, I want to share with you that this year I have received the prestigious big grant from BIRAC, and the topic of my research area I want to share with you. So this is the topic of natural identical vanillin production, biotransformation of agro. Hello friends, I want to introduce myself. My name is Dr. Pritam Chattopadhyay, and for the last 10 years I'm working on fermentation technology and host microbe interaction. So I have received the prestigious BIRAC big grant. Hello, my Dr. Presently, I am working as a professor in MU College, Bardhaman, University of Bardhaman. For last 10 years, I am working in the field of fermentation technology and plant microbe interaction. Presently, I got awarded about the previous big grant from BIRAC, and the topic of my research is scale up of natural identical vanillin production from biotransformation of agro waste. So I want to share with you some interesting points related to this. So this is the I want to share with you the present problem, the opportunity we are talking about. Okay, so the main opportunity is that we know that vanilla main organ of the vanilla flavor. We all it is almost every flavor of we use it in our cookies, our cakes, pastries, even and cosmetic also. So it has a very high demand. And current net production is about 20,000 per year. We say here about 8. But the main problem with the vanillin is that the natural vanillin is only 4 to 50 tons per year, which is less than 1% of the current net production. And the vanillin cost around 3,000 US dollar per kilo. Whereas chemical production is about production of chemical is about 8,000. So it's more than 90% of the current net production, which cost around $50 per kg. Now there is scope. What is that? The scope is for the nature identification. There is some difference between the line IPA and the EC line by European. However, there is no doubt that if use is nature identical cashier, then it will be termed as natural by internal agent. But the cost of fuelic acid is about 1,000 euros per kg. So here's the plan. If we have to market our to fermentation technology using fuelic acid as cashier, then what cost goes to the fuel because fuelic acid is very costly. So this is the problem. So for alternative, I have thought a brilliant opportunity for that. If we can produce this from the agro, we know that India is still a agro based. Indian economy is based on the agriculture, and every year we have generated any 1,000 tons of solid agro waste, and many times that is also causing some problem related to solid waste management. However, if our present proposal will also give a sustainable use of that agro waste. So the concept, where from the concept comes, in laboratory scale I have already done these experiments where I have used discharged wheat bran 100 gram per liter, and I have used some streptomyces strains isolated by me, characterized by me, and identified by me. So these strains can produce 0.075 gram per liter vanillin from 100 gram of per liter of wheat bran. So this is a laboratory scale result. You can also see the HPLC UV analysis of the fermented broth here. The first week is for the vanillic acid, then the vanillin, and then the ferulic acid. So if we can replicate this at industrial scale, so we can directly predict that approximately 1,334 kg of wheat bran is required to produce 1 kg vanillin, worth $1,000 US. Okay, so that means from 1,334 kg of wheat bran, which will hardly cost 500 rupees, we can generate from there 1,000 US. That means about 68,000 Indian rupees. So with the our starting material cost is 500 rupees, whereas the end product will be of 68,000 rupees, even in the laboratory scale. So if we can replicate it an industrial scale through scale up mechanism by pilot scale, obviously there is a very good hope for commercial success. Not only that, I have also fully characterized the biochemical pathway and the genes involved in this bioconversion pathway. The uniqueness of this bioconversion pathway is that this particular strain can convert agro waste into vanillin through ferulic acid in a single fermentation session. That is the beauty of this pathway, and this is the beauty of the streptomyces. And the other rationale behind utilizing streptomyces is that streptomyces is generally recognized as grass organism, so therefore it's quite safe to use developing products that which are consumable. So with the we have already published some papers related to pathways and genes, and please remember that the paper that I have already published with the strain that I am currently using for this project is entirely different. No data from this trend has reported yet, and this is the best trend that I have. I hope it will have a huge commercial success, and I want to thank Bayrak for providing me this grant. I want to help my incubation center, Guwahati, Naipa, and at the same time, our mentor from KIIT Bhubaneswar for helping me in each and every step. I also mm, hope that I will get their support for the entire duration of my project and making our own brand and commercialization of the product. Thank you. Thank you, friends. Bye.